iMeasure is a portable Android-based solution used for data collection and signal mapping for both indoor and outdoor wireless systems. With the solution, one can collect data on a wide range of bands and cellular technologies for surveying and on-site troubleshooting. Later, the collected data can be imported into a design platform, such as the ATEC DASCAD, to design and optimize network layers for indoor venues as well as outdoor areas. The components of the solution is the iMeasure master device, the iMeasure Bluetooth, the Hermes Transmitter, and the Hermes receiver. The iMeasure master device allows one to record and plot outdoor signal data using GPS coordinates and indoor data utilizing a preloaded building floor plan. The iMeasure app on the Bluetooth-enabled Android phone allows one to run test scenarios including FTP, HTTP, long and short voice calls, and then record the results of these tests. For CW data, the Hermes scanner receives test signals transmitted by the Hermes 6-port wideband portable transmitter and then connects to the iMeasure master device via USB for processing of the collected data. The Hermes CW transmitter transmits up to 6 simultaneous CW channels. To connect multiple antennas, there are 6 transmission ports. LED indicators turn green when a port is transmitting. The RF button gives one the option of turning individual ports on and off. Use the numeric keypad to enter the desired test frequencies and output power. The function buttons allow one to navigate the transmitter's menu options. The opening screen gives one the option to load the channels, settings, projects, and seek additional information on the transmitter's usage. Before starting a project, open the general menu of the iMeasure master device. Here one can set up indoor or outdoor point sizes, program how often iMeasure will update during an outdoor test, and enable or disable plot numbers from outdoor and indoor layout screens. In the thematic settings menu, one can select the collection device being used for testing and metrics based on the technology being recorded. For thematic plotting, one can assign colors that will represent the gathered signal strengths. One can also select the desired ranges and their labels depending on cell ID, RSSI, and other KPIs depending on their technology. With the testing menu, set the upload and download servers one would like to use for the test, and/or initiate a ping test. From the log file menu, choose the format, CSV or XML, that will be used to record the test, as well as the plot points one would like to output. Here, one can also share the recorded data to an email address or Google Drive account. On the Bluetooth sync page, sync the Bluetooth devices being used for the test with the iMeasure master device. Wi-Fi measurements can be included and can be sorted by the connected Wi-Fi, dominant access point, or a specific SSID. On the Hermes RX setting page, set the receiver specifications for the test, such as samples per second, frequencies, and binning options. For this demonstration, we will collect cellular data on one Bluetooth device and one CW signal utilizing the Hermes transmitter and receiver. There are 6 antenna inputs on the Hermes transmitter. Depending on the number of frequencies for which you would like to collect data, attach the appropriate number of antennas. Here, we only use one antenna for one channel. On the transmitter, set up channel 1 with the desired frequency. For this test, we will program 700 MHz and then set an output power of 1 dBm. Go to the RF button, select the channel 1 port, and press Run. When the transmitter is transmitting, the indicator on the screen will turn green, and the LED indicator will illuminate. Once you're transmitting, set up the iMeasure master by selecting Indoor Test. Begin by clearing the data from any previous test, and start a new session. Sync the Bluetooth-enabled device to the iMeasure master. And then select the device on the iMeasure Master. The sync icon will turn green when the device is connected. Connect the Hermes receiver to the iMeasure Master via the USB input. Then, on the iMeasure Master device, scroll down to the Hermes RX and turn it on. Select the samples per second, the frequency, the binning, and save the specifications. Allow access to the Hermes receiver to the iMeasure Master and click Save. Enter the pertinent location information for the test, such as site name, floor number, etc., and click Save. The location's floor plan will appear, and at the bottom of the screen one will see the Hermes frequencies, RSSI, and the Bluetooth device. To begin gathering data, press Record and mark your initial plot point on the floor plan. Gather the iMeasure Master, Hermes receiver, and Bluetooth device and begin to walk the space. Create a plot point on the floor plan every time you change a direction. Once the survey is complete, save the session. One can review the results on the iMeasure Master by reloading the session. For this demonstration, we will look at the 700 MHz test recorded with the Hermes receiver. One can see the floor plan, the survey route, and the thematic range of colors that denote the signal range in specific areas of the location. The ATEC solution can also assess public safety signals utilizing either a walking test or in a grid format. Here, we'll demonstrate a grid test. To begin, attach the Hermes receiver to the iMeasure Master device and select the Hermes scanner. Select Public Safety from the Technology drop-down menu and then select the decoder. For this demo, we will use P25 Phase 1. Select the desired modulation, normal or simulcast, and the frequencies to be tested. Once the frequencies are selected, one can adjust the sensitivity and select the messages one would like to record. Then, save your settings. From the Settings menu, select Start New Session. Choose a floor plan that has been preloaded into the iMeasure Master device and insert your company's logo and name. Then, enable grid testing and set the parameters for your grid. Here, we will choose 7 horizontal columns and 7 vertical rows. Add the project name and other pertinent information. Save the information and the floor plan will appear. If you would like to confirm the live data being received by the iMeasure Master device, select P25 from the menu. Here, you will find the frequencies, RSSI, SINR, BER, NEC, Site ID, Channel ID, DUID, and the selected thematic color. Once you are done, return to the floor plan and create a grid for the test. A grid is created by placing plot points on the floor plan. The grid will appear as an overlay, which defines the specific areas for testing. Start to record and begin your test. The receiver and the iMeasure Master must be physically positioned in the area of the location that coincides with the selected area on the floor plan. If the recorded signals in a selected area meet your requirements, the area on the floor plan will turn green. If it does not meet your requirements, the area will turn red. When the results of the area are recorded, move on to the next section of the location to be tested. To conduct an outdoor test, connect the Bluetooth device or the Hermes receiver to an Android device with iMeasure and GPS. Make sure you are receiving a signal, press record, and drive the area you wish to survey. Positions will be defined by the GPS coordinates. Once your session is recorded, it can be imported into a post-processing tool for plotting each of the recorded KPIs. the iMeasure collected data can be imported and viewed on the DASCAD network planning platform, where engineers can utilize its advanced ray tracing prediction engine to understand and simulate network coverage and traffic. In DASCAD, engineers can model complex building structures such as stadiums and airports. After building these models, engineers can build detailed wiring diagrams and generate an accurate bill of material. DASCAD enables engineers to then generate advanced predictions of network coverage, quality, and performance to study new or modify existing designs. DASCAD also allows users to combine coverage studies with traffic analysis. In one platform, engineers can study both in-building and outdoor networks and analyze the interaction between the two. The lightweight and portable design of ATEC Solutions portfolio allows one to conduct comprehensive coverage studies in every type of location, and is essential for network professionals to easily and effectively assess existing wireless networks and carry out their design, optimization, and network deployment activities.